The morning of June 4th, 1942, broke clear over the Central Pacific. Lieutenant Tomonaga's scout plane banked eastward from the Japanese carrier strike force, searching the empty ocean for American ships that intelligence insisted weren't there. The American carriers Enterprise and Hornet were supposedly lurking somewhere in these waters. Admiral Nagumo's staff had studied the intelligence reports carefully. 2 carriers maximum. Japan's 4-carrier strike force held overwhelming numerical superiority. Then Tomonaga's radio crackled to life at 9:55 a.m. Sight what appears to be 10 enemy surface ships, bearing 010 degrees, distance 240 miles from Midway. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Nagumo's intelligence officer noted the report without concern. 10 surface ships meant cruisers and destroyers. The Americans were trying to defend Midway with surface vessels. Predictable. Futile. 15 minutes later, another message. Enemy ships accompanied by what appears to be a carrier. The operations room aboard the flagship Akagi went silent. 1 carrier. That matched intelligence. Either Enterprise or Hornet had been spotted. Uncomfortable, but manageable. Then, at 10:20 a.m., a 3rd radio transmission arrived that changed everything. 2 additional carriers sighted. 3 American carriers. 3. Every officer in that operations room knew what that meant. The Americans weren't supposed to have 3 carriers in the Pacific. They'd lost Lexington at Coral Sea just 2 weeks earlier. Yorktown had been crippled in that same battle. Photographed burning and listing, reported as probably sunk or at minimum requiring months of repairs at a mainland shipyard. But reconnaissance doesn't lie. 3 carriers were launching aircraft against the Japanese fleet at that very moment. One of those carriers was a ghost ship that shouldn't exist. Admiral Nagumo's staff frantically recalculated their attack plans while trying to solve an impossible puzzle. If Yorktown was dead or crippled, what was that 3rd carrier? Had the Americans somehow rushed a new carrier from the Atlantic? Had their intelligence missed an entire capital ship? The confusion would cost them precious minutes they didn't have. Minutes that would decide the Battle of Midway and possibly the entire Pacific War. What the Japanese didn't know, couldn't have imagined, was that Yorktown wasn't just afloat. She was combat ready. Between May 7th, when Japanese pilots had left her burning in the Coral Sea, and June 4th, when she launched aircraft at Midway, exactly 28 days had elapsed. In those 4 weeks, American welders had performed a miracle that violated every assumption Japanese naval planners had made about carrier warfare. The assumptions weren't unreasonable. They were based on how every navy in the world understood ship repair. When a carrier suffered serious damage, structural damage that cracked armor plating and buckled flight decks, that ship returned to a major shipyard for extensive repairs. You couldn't patch a carrier like you'd patch a car. These were floating cities displacing 20,000 tons, with flight decks spanning hundreds of feet, powered by complex steam systems, and armored with inches of steel. Repairing serious battle damage required dry docks, heavy machinery, and teams of specialized craftsmen working for months. The Japanese knew this from experience. Their own carriers damaged in combat operations went to shipyards like Kure or Yokosuka, where hundreds of workers swarmed the damaged sections for 8 to 12 weeks. That was the standard timeline across all navies. British carriers damaged in Mediterranean operations sailed home to Portsmouth or Birkenhead for similar repair schedules. German surface raiders that took battle damage limped back to Bremen or Wilhelmshaven for months-long overhauls. Carrier warfare in 1942 operated under brutal mathematics. Both sides possessed limited numbers of these precious ships. America had started the war with 7 fleet carriers. Japan had begun with 6. Losing even 1 carrier represented a catastrophic blow. Crippling one for 3 months was nearly as bad. That carrier couldn't launch strikes, couldn't defend the fleet, couldn't project power. It was dead weight consuming fuel and occupying trained crews while contributing nothing to the war effort. This reality shaped Japanese strategy after the Battle of Coral Sea. On May 7th and 8th, 1942, American and Japanese carrier forces had fought the first naval battle where opposing ships never saw each other. Aircraft did all the fighting. The Americans lost Lexington, sunk by multiple torpedo and bomb hits. The Japanese lost the light carrier Shoho and saw the fleet carrier Shokaku severely damaged. But the exchange that mattered most to Japanese planners involved Yorktown. Multiple dive bombers had hit her, penetrating the flight deck with bombs that exploded deep inside the ship. Reconnaissance photographs showed Yorktown listing, burning, dead in the water. Japanese pilots reported leaving her crippled and probably sinking. Even if she somehow stayed afloat, Japanese intelligence estimated Yorktown would require 90 days minimum in a major shipyard to repair that level of structural damage. 90 days meant she'd miss every significant operation through summer and early fall of 1942. That assessment was sound naval engineering. Every navy in the world would have made the same calculation. Yorktown limped into Pearl Harbor on May 27, 1942, looking exactly as bad as Japanese intelligence believed. The flight deck had a massive crater where bombs had blasted through the wooden planking and steel plates underneath. Bomb explosions had buckled frames 3 decks down. Fuel lines were ruptured. The island superstructure showed fire damage. Below decks, compartments were flooded, electrical systems were fried, and the crew had been fighting fires for 2 days straight. Admiral Chester Nimitz came aboard personally to inspect the damage. He walked the flight deck, climbed down into the damaged sections, and asked the question everyone was thinking. "Can you make her ready for combat?" The shipyard supervisor, Captain John Smith, was a civilian engineer who'd been building and repairing ships at Pearl Harbor for 20 years. He'd seen every kind of damage the ocean and enemy could inflict. He studied the crater in Yorktown's flight deck, examined the buckled frames below, checked the lists of damaged systems, and delivered his professional assessment. 90 days in dry dock. Minimum. Nimitz nodded. He'd expected that answer. Traditional ship repair doctrine required methodical work. Remove damaged sections. Fabricate replacement parts. Install new components. Test systems. Each step consuming days or weeks because you couldn't rush structural repairs without compromising safety. "You have 3 days, Nimitz said. Captain Smith thought the Admiral was joking. When he realized Nimitz was serious, he started explaining why 3 days was physically impossible. The flight deck needed complete replacement in the damaged area. The structural frames below required cutting out and welding in new steel. The fuel lines, electrical conduits, ventilation systems, all needed repairs that required specialized workers following careful procedures. Nimitz cut him off. "Intelligence indicates the Japanese are planning a major operation at Midway. We need every carrier we can get combat ready. Yorktown has 3 days. It wasn't a request. It was reality. The Japanese were coming. The Americans needed that third carrier or Midway would fall, and the entire Pacific defensive perimeter would collapse. 3 days to fix 90 days' worth of damage. Smith understood he wasn't being asked whether it could be done. He was being ordered to do it anyway. What happened over the next 72 hours redefined what American forces believed was possible. It started with Smith abandoning every traditional ship repair protocol. Normally, you'd assess all damage, create a comprehensive repair plan, order materials, schedule work crews, and proceed methodically through a prioritized task list. Smith threw that approach away. He gathered every available worker at Pearl Harbor, Navy personnel, civilian contractors, shipyard staff, approximately 1,400 people, and told them they'd be working continuously for 3 days. No shift schedules, no breaks, just constant work until Yorktown could sail and fight. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. He divided the work into parallel operations. Traditional ship repair was sequential. Finish the hull repairs, then fix the systems inside, then test everything. Smith's team would do everything simultaneously. Hull welders would repair structural damage while electricians ran new wiring, while pipe fitters replaced fuel lines, while carpenters rebuilt the flight deck surface. Hundreds of workers crammed into damaged spaces, working shoulder to shoulder, somehow not interfering with each other. The flight deck repair was the most visible and most critical work. The bomb crater measured roughly 30 feet across and penetrated 3 decks down. Traditional repairs would cut away all damaged material back to undamaged steel, fabricate new deck sections in a workshop, then crane them into position and weld them permanently. Smith's team didn't have time for fabrication. They needed something faster. The solution came from welding techniques developed in Liberty ship construction. Prefabricated steel plates, already cut to standard sizes, could be welded directly over damaged sections. Not proper repairs, but combat-ready patches that would hold until proper repairs could be made after the battle. The welding teams worked around the clock. These weren't traditional shipwrights who'd apprenticed for years learning to rivet ships the way their fathers and grandfathers had done. These were newer workers trained in electric arc welding, the same technique Henry Kaiser's shipyards were using to revolutionize merchant ship construction. Welding was faster than riveting by an order of magnitude. A riveted joint required multiple workers with specialized roles, heating rivets, tossing them, catching them, bucking them, hammering them. Each rivet took time. A welded joint required one skilled worker with an electrode holder who could fuse steel plates together in seconds. The welders on Yorktown's flight deck worked in rotation. One team would lay beads for 30 minutes, then step aside exhausted while a fresh team took over. The work was brutal. Electric arc welding generates temperatures around 3,600 degrees Fahrenheit. The electrode creates brilliant white light that burns your retinas if you watch without protection. Molten metal spatters everywhere, burning through clothing, scarring exposed skin. The fumes are toxic. The physical toll of holding a 10-pound welding stinger in position for hours while maintaining precise electrode angles destroys your shoulders and back. But it was fast. Where traditional repairs might have taken weeks to cut out damaged sections and rivet new plates, welders were laying continuous seams across Yorktown's flight deck in hours. Below decks, the repairs got more complicated. The bomb explosions had buckled structural frames, the massive steel ribs that gave the carrier its strength. These frames weren't cosmetic. They held the entire ship together, distributed loads from the flight deck and armor plating, and prevented the hull from flexing and breaking in heavy seas. Traditional frame repairs required cutting out the damaged section completely, fabricating a replacement frame in a machine shop, and installing it with precise alignment before welding or riveting it permanently. This process took weeks for a single frame. Yorktown had multiple frames damaged. Smith's solution was another radical departure from doctrine. Instead of replacing damaged frames, they'd reinforce them. Welders cut thick steel plates and welded them directly across the buckled areas, effectively splinting the damaged frames like you'd splint a broken bone. It wasn't pretty. It wasn't permanent, but it restored enough structural strength for combat operations. The fuel system repairs required even more creativity. Yorktown's aviation gasoline system was a complex network of pumps, pipes, and valves that distributed high-octane fuel from storage tanks deep in the ship up to refueling stations on the flight deck. The bomb damage had ruptured multiple fuel lines, contaminated tanks, and damaged pumps. Pipe fitters swarmed through the damaged sections, cutting out ruptured pipes and welding in replacement sections. The work was dangerous. Aviation gasoline fumes are explosive. One spark from a welding torch in the wrong location would trigger a catastrophic explosion. The fitters had to verify every space was properly ventilated, clear of fumes, and safe before striking an arc. They worked anyway. Because Nimitz had given them 3 days, and 3 days was what they'd take whether it killed them or not. Electricians re-ran miles of wiring. The bomb explosions and fires had destroyed electrical conduits throughout the damaged sections. Without power, the ship couldn't operate radar, radio, or damage control systems. The electricians stripped out burned wiring and pulled new cables through undamaged conduits, working in cramped, unventilated spaces lit by handheld work lights. Carpenters rebuilt the wooden flight deck surface. Fleet carriers used thick wooden planking over the steel flight deck to provide better traction for aircraft, and to reduce weight compared to solid steel. The bomb damage had destroyed large sections of this wooden deck. Carpenters cut and fitted new planks, working from dawn until they couldn't see anymore, then continuing under floodlights. The entire repair operation violated fundamental safety protocols. Welders working directly above pipe fitters. Electricians routing cables through spaces where carpenters were sawing planks. Everyone breathing toxic fumes, everyone exhausted, everyone knowing that cutting corners might create weaknesses that would fail during combat. But they also knew that not finishing meant Yorktown wouldn't sail, and if Yorktown didn't sail, the Japanese would win at Midway. So they worked. 1,400 people performing 90 days of repairs in 72 hours through sheer stubborn refusal to accept physical limitations. Admiral Nimitz visited the ship multiple times during the repair marathon, climbing through damaged spaces, thanking workers personally, checking progress against the timeline. He needed Yorktown combat ready by May 30th. That was the absolute deadline. After that, she'd be too late to reach the intercept point where intelligence indicated the Japanese carriers would be. The workers knew about Midway. Security was supposedly tight, but 1,400 people working that frantically on emergency repairs could figure out something major was coming. They understood the stakes. This wasn't routine maintenance. This was a race against an enemy fleet already underway. On the morning of May 30th, 66 hours after entering Pearl Harbor, Yorktown cast off her moorings and headed for open water. The flight deck had been patched, the structural frames had been reinforced, the fuel systems functioned, the electrical systems worked. None of it was proper, none of it was permanent, but all of it was combat ready. Captain Smith stood on the dock, watching Yorktown disappear over the horizon, and wondered if his hurried repairs would hold when bombs started falling again. He'd cut every corner he could find, used welds where regulations demanded rivets, splinted frames instead of replacing them, patched systems instead of properly rebuilding them. If Yorktown broke apart in heavy seas or caught fire from a fuel system failure or lost structural integrity under combat stress, it would be his fault. He'd know in about 5 days when Yorktown reached Midway and met the Japanese carrier force. Until then, he could only hope American welders had managed something impossible. They had. The Japanese scouts' report of 3 American carriers at Midway triggered chaos aboard Admiral Nagumo's flagship. The operations staff had been preparing to launch a second strike on Midway Island's facilities when the scouts' message arrived. Now they had to pivot immediately to attacking carriers, which required different ordnance and different tactics. Bombs needed to come off aircraft, torpedoes needed to go on, fuel tanks needed to be topped off. Flight deck crews scrambled to rearm the strike aircraft, while Nagumo's staff recalculated attack vectors and timing. But underneath the tactical chaos was a deeper confusion that nobody had time to address. 3 carriers. The Americans weren't supposed to have 3 carriers. Where had the third one come from? The answer was steaming toward them at flank speed, her patched flight deck launching dive bombers and torpedo planes, her welded structural frames holding together despite the stress, her splintered fuel systems delivering aviation gasoline to thirsty aircraft engines. Yorktown was supposed to be dead or crippled. Instead, she was fighting. And her presence at Midway represented something far more significant than just one additional carrier. It represented a fundamental American advantage that Japanese planners had never anticipated: the ability to return crippled ships to combat in days instead of months, the industrial capacity to perform battlefield repairs that other navies considered impossible, the welding technology and damage control expertise that treated carriers like broken machines that could be patched and sent back into the fight. The Japanese had built beautiful carriers with elegant engineering and proper construction techniques. The Americans had built carriers they could fix fast with welders and determination and contempt for what shipbuilding tradition said was impossible. At Midway, that difference would matter more than anyone realized. The American approach to carrier damage control didn't begin at Pearl Harbor in May 1942. It had been developing quietly for years, driven by an industrial philosophy fundamentally different from how other navies approached ship construction and repair. Understanding why American welders could patch Yorktown in 3 days requires understanding how American shipbuilding had diverged from centuries of maritime tradition. Traditional ship construction was craft-based. Master shipwrights trained for decades, learning techniques passed down through generations. Ships were built slowly, carefully, with an emphasis on elegance and permanence. European and Japanese shipyards produced vessels of extraordinary quality, where every joint was precisely fitted, every rivet perfectly placed, every system installed according to exacting standards. This craft tradition produced magnificent ships, but it also produced a repair mentality that treated damaged vessels as precious artifacts, requiring months of careful restoration. When a Japanese carrier returned to Kure Naval Arsenal with battle damage, hundreds of skilled craftsmen would methodically rebuild the damaged sections to original specifications. Quality was paramount. Speed was secondary. American shipbuilding, particularly after 1940, took a radically different approach. Henry Kaiser's Liberty Ship program had proven that ordinary workers with minimal training could build ocean-going vessels in weeks instead of months, using mass production techniques and welding instead of riveting. That revolution in merchant ship construction influenced everything else American industry touched, including warship construction and repair. The Navy's Bureau of Ships studied Kaiser's methods and recognized their potential application to damage control. If welders could build ships faster than riveters, welders could repair ships faster too. Starting in 1941, the Navy began training damage control teams in electric arc welding techniques, specifically for battlefield repairs. These weren't traditional ship fitters. They were more like battlefield surgeons, trained to stabilize critical damage quickly, rather than restore original perfection. Their mission was getting ships back into combat, not making them beautiful. The difference in philosophy showed in their equipment. Traditional ship repair teams carried precision measuring tools, proper cutting, equipment, and materials for fabricating replacement components exactly to specification. American damage control teams carried portable welding generators, stockpiles of pre-cut steel plates, and instructions to patch first and worry about proper repairs later. The carriers themselves were designed with this repair philosophy in mind. American fleet carriers built after 1939 included extensive internal workshops equipped with welding stations, metal cutting equipment, and stockpiles of spare materials. The theory was simple. If you could perform basic repairs without returning to port, you could keep fighting. Japanese carriers had similar workshops, but smaller and less comprehensive. The Japanese Navy assumed major repairs required shipyard facilities. Their onboard workshops handled routine maintenance and minor damage. The Americans assumed major repairs might need to happen at sea in the middle of combat operations. This difference reflected deeper cultural attitudes about craftsmanship versus utility. Japanese naval architecture prized elegant solutions and aesthetic perfection. American naval architecture prized functionality and speed of construction. Neither approach was objectively better, but in wartime, functionality and speed proved more valuable than perfection. The damage control training reflected these priorities. Japanese damage control teams received extensive instruction in firefighting, flooding control, and emergency repairs using traditional techniques. American teams received the same training plus intensive welding instruction. Every American carrier deployed with multiple qualified welders who could perform structural repairs under combat conditions. The welding equipment itself represented American industrial advantages. Portable electric generators small enough to maneuver through ship passageways, but powerful enough to run welding equipment, had only become available in the late 1930s. American manufacturers produced these generators by the thousands for industrial and military use. Japanese industry produced fewer, and what they did produce was allocated primarily to shore facilities. This meant American carriers could generate enough electrical power anywhere on the ship to support welding operations. Japanese carriers could weld in their main workshops, but struggled to bring welding equipment to damaged areas. The difference seemed minor until battle damage left a carrier crippled. Then, having portable welding generators and trained operators became the difference between returning to combat or withdrawing to port. Yorktown's 3-day repair at Pearl Harbor had proven the concept worked. But the real test came on June 4, 1942, when Japanese dive bombers found her at Midway and put 3 bombs into her again. The first bomb hit at noon, penetrating the flight deck amidships and exploding inside the ship. The blast ruptured fuel lines, started fires, and killed dozens of men. The second bomb struck minutes later, hitting near the island superstructure and knocking out multiple boiler rooms. Yorktown lost power. Her speed dropped from 30 knots to barely 6 knots as fires raged below decks. The third bomb hit aft, blowing another hole in the flight deck and destroying the ship's radar systems. Within 10 minutes, Yorktown was dead in the water, burning, and apparently finished. Japanese pilots radioed back that they'd crippled the American carrier. Admiral Nagumo's staff noted the report with satisfaction. That mysterious third carrier was eliminated. The tactical balance had shifted back toward Japan. They were wrong, again. Captain Elliot Buckmaster, Yorktown's commanding officer, had no intention of abandoning ship or withdrawing from combat. The moment the attack ended, he ordered damage control teams into action. Fire parties attacked the blazes with fog nozzles and chemical foam. Welding teams grabbed their portable generators and headed toward the damaged sections. Hull repair parties broke out their stockpiles of pre-cut steel plates and started evaluating what needed patching. The bomb that knocked out the boiler rooms had created Yorktown's most critical problem. Without steam, the ship couldn't move. Without movement, she was a sitting target for the next Japanese attack. The boilers themselves were intact, but the bomb's blast had ruptured steam lines feeding the turbines. Hot steam under tremendous pressure was venting into enclosed spaces, making them uninhabitable. The welding team assigned to the engineering spaces faced an impossible task. They needed to weld shut ruptured steam lines while those lines were still hot, still under pressure, and venting live steam that could cook a man alive in seconds. Traditional ship repair doctrine said you shut down the system completely, let everything cool, then perform repairs in safe conditions. The welders climbed into the damaged spaces, anyway. They wore asbestos suits that provided minimal protection against the superheated steam. They worked in teams, one man welding while 2 others stood ready to drag him out if he collapsed from heat exhaustion. The lead welder positioned himself as close to the ruptured steam line as he could tolerate, struck an arc, and started laying beads across the rupture, while steam scalded his protective equipment. The weld didn't need to be pretty, it needed to hold pressure. He worked fast, laying rough beads that would have embarrassed any peacetime shipfitter but accomplished the mission. Within 20 minutes, the rupture was sealed. The boiler could rebuild pressure, the turbines could turn, Yorktown could move. Captain Buckmaster ordered the engines relit. Within an hour of being bombed into immobility, Yorktown was making 20 knots. The Japanese had left her dead in the water. American welders had brought her back to life in 60 minutes. The flight deck repairs proceeded, simultaneously. The bomb craters couldn't be properly fixed, not out here in open ocean without dry dock facilities or proper materials, but they could be covered. Damage control teams dragged steel plates across the flight deck and positioned them over the holes. Welders followed behind, tack welding the plates in place. Not permanent welds, just enough to hold the plates down and create a surface aircraft could roll across. By 1:30 p.m., 90 minutes after the attack, Yorktown was recovering aircraft. Her flight deck was a patchwork of welded plates and hastily repaired sections, but aircraft could land on it. Pilots from Enterprise and Hornet, who'd been orbiting with low fuel set down on Yorktown's scarred deck, refueled from her splintered fuel systems and took off again to continue attacking the Japanese fleet. To Japanese observers watching through binoculars from their own carriers, this was incomprehensible. They'd just bombed that American carrier into a crippled wreck. Now it was launching and recovering aircraft like nothing had happened. How was this possible? What kind of damage control could restore a crippled carrier to operations in under 2 hours? The answer was American welders performing battlefield repairs that Japanese damage control doctrine considered impossible. But the demonstration wasn't finished. At 2:45 p.m., a second Japanese strike wave found Yorktown. This time it was torpedo bombers. 2 torpedoes slammed into Yorktown's port side, tearing massive holes below the waterline. The ship took on an immediate 17-degree list. Seawater flooded multiple compartments. The electrical system failed completely. All power was lost. Captain Buckmaster surveyed the damage and made the hardest decision of his career. This time, the damage was too severe. Yorktown was going to capsize. He ordered abandon ship. The crew evacuated in good order, climbing down into life rafts and small boats while the carrier rolled further, onto her side. But even abandoning ship, even accepting that Yorktown was finished, American damage control philosophy differed from Japanese doctrine. The Japanese would have left the sinking carrier behind and moved on. The Americans refused to give up. Within hours of the crew evacuating, salvage teams returned to Yorktown's sloping decks and started working to save her. They couldn't weld underwater hull ruptures. Those were beyond battlefield repair capabilities, but they could counterflood compartments on the starboard side to reduce the list. They could rig pumps to remove water from flooded spaces. They could stabilize the ship enough to take her under tow back to Pearl Harbor for proper repairs. Throughout June 5th and 6th, salvage crews worked aboard the abandoned carrier, slowly bringing her list under control. By June 6th, Yorktown was nearly upright, under tow, and seemingly heading for survival. Then, a Japanese submarine found her and put 2 more torpedoes into her damaged hull. This time, the damage was truly catastrophic. Yorktown capsized and sank on June 7th, but she'd survived 3 days after being hit by multiple bombs and torpedoes. She'd returned to combat operations twice after attacks that should have crippled her. And she demonstrated a fundamental truth about American carrier operations. American damage control could return crippled ships to combat faster than Japanese planning assumed was possible. The strategic implications rippled through the rest of the Pacific War. Japanese intelligence officers studied Yorktown's performance at Midway and revised their estimates of how long American carriers stayed out of action after taking damage. The new estimates acknowledged that American damage control might restore combat capability in hours or days rather than weeks or months. This realization forced changes in Japanese tactical doctrine. Previously, Japanese commanders had assumed that damaging an American carrier removed it from combat for the duration of a battle. Now they understood they needed to sink American carriers outright because crippling them might only put them out of action temporarily. But achieving kills instead of damage required more ordnance, more strikes, more risk, and by mid-1942, Japan was already losing the production war. They couldn't afford to expend extra resources, ensuring American carriers stayed dead when they needed those resources to attack more targets. The American advantages multiplied throughout 1943 and 44. As the war progressed, U.S. Navy damage control teams became extraordinarily proficient at battlefield repairs. Carriers returning from combat would arrive at forward bases like Ulithi or Majuro with extensive battle damage, spend 48 to 72 hours getting patched by mobile repair ships, and return to combat without ever seeing a major shipyard. The repair ships themselves represented American industrial philosophy. These were floating shipyards, essentially, equipped with machine shops, welding stations, foundries, and stockpiles of spare parts. They could manufacture replacement components, perform structural welding, and restore combat capabilities to damaged vessels far from any permanent naval facility. The Japanese had no equivalent capability. Their damaged ships had to return to Japan for repairs, taking them out of combat for weeks or months. USS Enterprise demonstrated this advantage repeatedly. She was hit multiple times throughout 1942 and 43, suffering damage that would have sent any other nation's carrier home for months. Instead, Enterprise would pull into Noumea or Espiritu Santo, where repair ship crews would swarm aboard with welding equipment and spare parts, patch her up in days, and send her back into combat. By late 1943, Enterprise had earned the nickname the Grey Ghost because Japanese propaganda kept announcing her destruction while she kept reappearing in combat. The nickname wasn't really about her ability to avoid damage. It was about her ability to absorb damage and keep fighting thanks to American welding technology and damage control expertise. The contrast with Japanese carriers was stark. When Shokaku returned to Japan after Coral Sea with bomb damage similar to what Yorktown had sustained, she spent 3 months under repair at Kure Naval Arsenal. Craftsmen meticulously rebuilt her damaged sections to original specifications. The repairs were perfect. The delay was crippling. Shokaku missed the Battle of Midway entirely because she was still under repair. If Japanese damage control had been able to patch her in days instead of months, she would have been part of Nagumo's strike force. The Battle of Midway might have ended differently. The entire Pacific War might have followed a different trajectory, but Japanese naval architecture and repair philosophy didn't support that kind of rapid repair. Their ships were beautifully constructed with traditional techniques that didn't translate well to battlefield conditions. Their damage control teams were skilled but trained in methods that prioritized proper repairs over fast repairs. Their industrial base produced exquisite craftsmanship but lacked the portable generators, welding equipment, and mass-produced spare parts that enabled American-style damage control. This wasn't a question of Japanese competence. Their shipbuilders were extraordinarily skilled. Their damage control teams were brave and dedicated, but they were working within a naval tradition that hadn't adapted to total industrial warfare the way American industry had. The Americans had thrown away the rulebook. They'd embraced welding over riveting, prefabrication over custom work, good enough over perfect, and fast over slow. Those choices had been controversial when Henry Kaiser first applied them to Liberty ship construction. Traditional maritime experts had predicted disaster. Welded ships would crack. Rushed construction would fail. Instead, welded construction proved stronger than riveting when done properly, and American damage control teams proved that good enough repairs performed in hours could keep ships fighting while perfect repairs performed in months left ships idle. By 1944, the U.S. Navy was operating carrier task forces that could absorb damage and continue operating in ways that Japanese planners found almost supernatural. At the Battle of Philippine Sea in June 1944, American carriers took multiple bomb and kamikaze hits. Damage control teams put out fires, patched holes, and restored combat operations so quickly that pilots returning from strikes sometimes couldn't tell which carriers had been hit. The Japanese had no answer for this. Their own carriers damaged at Philippine Sea had to withdraw from combat immediately. The Americans patched and kept fighting. The battle ended with American carriers recovering aircraft and preparing for another strike, while Japanese carriers limped toward home ports. The pattern repeated throughout the Pacific campaign. American carriers absorbed damage that would have crippled Japanese vessels, spent hours or days getting patched by welders and damage control teams, and returned to combat while Japanese carriers withdrew for months-long repairs. This wasn't occasional. It was systematic. It represented a fundamental advantage in how the two navies approached damage control and repair. Japanese admirals planning operations in late 1942 and throughout 1943 faced an impossible calculation problem. How do you plan a campaign when enemy carriers you damage at the start of the operation might be combat-ready again before the operation concludes? Traditional naval planning assumed damaged carriers were effectively sunk for strategic purposes. Remove them from your order of battle calculations. Plan as if they don't exist. But American carriers kept reappearing. Intelligence would report a carrier crippled. Japanese planners would adjust their force estimates accordingly. Then reconnaissance would spot that same carrier launching strikes a week later. The Americans were violating fundamental assumptions about how naval warfare worked. The title of this story mentions 6 hours. That number comes from Japanese post-war analysis of American damage control performance. Japanese naval officers studying American carrier operations after the war calculated that the average time between an American carrier suffering significant combat damage and that carrier resuming flight operations was approximately 6 hours. 6 hours. Not 6 days, not 6 weeks. 6 hours from bombs penetrating the flight deck to aircraft landing and taking off again. That timeline was incomprehensible to officers trained in traditional naval damage control. 6 hours wasn't enough time to properly assess damage, let alone repair it. Yet the Americans consistently achieved it. The secret was those welders and their portable generators and their stockpiles of pre-cut steel plates and their complete disregard for proper shipbuilding technique. They didn't repair damage, they stabilized it. They covered holes instead of replacing damaged sections. They splinted frames instead of cutting them out. They patched systems instead of rebuilding them. Every shortcut violated peacetime regulations. Every shortcut kept carriers fighting. Japanese damage control teams were brave. They fought fires with extraordinary courage. They managed flooding. They performed emergency repairs under terrible conditions. But they didn't have the welding equipment, the spare materials, the training, or the doctrine to perform the kind of rapid structural repairs American teams accomplished routinely. This advantage compounded as the war progressed. By 1944, American industrial production was delivering new Essex-class carriers at a rate of roughly 1 per month. These carriers incorporated all the lessons learned from earlier combat, larger internal workshops, more extensive spare parts inventories, better damage control equipment, more welding stations built into the ship's structure. Meanwhile, Japanese carrier production had essentially stopped. They'd lost too many experienced pilots, too much industrial capacity, too many critical resources. The carriers they had left became increasingly precious because they couldn't be replaced, which made Japanese admirals even more cautious about risking them in combat. Which meant American carriers dominated the Pacific, while Japanese carriers hid in port or withdrew from battles they might have won if they'd stayed engaged. The Battle of Leyte Gulf in October 1944 demonstrated this disparity devastatingly. Japanese carriers served as decoys, intentionally sacrificing themselves to draw American forces away from the main battle. Their role wasn't to fight, it was to die attractively while drawing attention. That's what had become of the Imperial Japanese Navy's carrier force. Beautiful ships with skilled crews reduced to bait because Japan couldn't afford to lose them in actual combat. American carriers, by contrast, fought aggressively throughout Leyte Gulf because American doctrine assumed carriers could take damage and keep fighting. And when they did take damage, welders and damage control teams proved that assumption correct. Carriers hit by kamikazes were patched and back in action within hours. The Japanese had no counter to this resilience. The welding technology that enabled American damage control had been controversial when first introduced. Traditional maritime experts had argued that welded construction was inferior to riveting. They'd predicted catastrophic failures. They'd insisted proper ship repair required traditional techniques and proper timeframes. The Liberty ship fractures in 1943 had seemed to validate those concerns. Welded ships were cracking. The experts had been right. Except the experts had been wrong about the underlying problem. The fractures weren't caused by welding being inferior to riveting. They were caused by poor steel quality, inadequate weld technique, and stress concentrations at sharp corners. Once those issues were addressed, welded construction proved superior to riveting in every measurable way. Stronger joints, faster construction, easier repairs, better watertight integrity. By 1944, welding had become the standard for all American naval construction and repair. New carriers were entirely welded. Older carriers received welded patches when damaged. The Navy's Bureau of Ships published detailed welding specifications and training manuals. Welding schools trained thousands of operators who could perform structural repairs anywhere in the fleet. The Japanese never caught up. They continued building ships using traditional riveting techniques refined over decades. Their craftsmanship remained extraordinary, but craftsmanship couldn't compete with industrial efficiency in total war. American welders could patch a carrier in hours. Japanese craftsmen needed months to restore one properly. Both approaches worked. Only one worked fast enough to matter in combat. The human cost of this technological advantage rarely gets discussed in histories focused on battles and strategies. But the reality was that American damage control saved thousands of lives. Carriers that could be patched and kept floating gave their crews a chance to survive. Carriers that had to be abandoned sank with men still trapped inside. The damage control parties themselves paid a terrible price for their effectiveness. Working inside damaged carriers, while fires raged, while bulkheads threatened to collapse, while ammunition cooked off in nearby magazines, these men performed some of the most dangerous work in the entire Navy, welding in smoke-filled compartments, cutting through twisted steel while the ship rolled in heavy seas, fighting fires that regenerated faster than foam could suppress them. Many damage control personnel died keeping their ships afloat. They were electrocuted by damaged electrical systems, burned by ruptured steam lines, crushed by collapsing structures, poisoned by toxic fumes. Their deaths rarely made headlines because they happened below decks away from cameras, but their sacrifice enabled everything else. The welders who patched Yorktown at Pearl Harbor in May 1942 were ordinary workers performing extraordinary work under impossible deadlines. Most of their names are lost to history. No monuments commemorate their 72-hour marathon that returned Yorktown to combat, but their work changed the Battle of Midway and possibly the entire Pacific War. If Yorktown hadn't been at Midway, the Americans would have engaged the Japanese carrier force with only Enterprise and Hornet. 2 carriers against 4. The numerical disadvantage might have been decisive. Japanese carriers might have survived to continue operating in the Pacific, prolonging the war by months or years. Instead, Yorktown's presence gave the Americans rough parity. 3 carriers against 4 was a fight the Americans could win, especially with superior intelligence about Japanese fleet positions. The battle turned on many factors, but Yorktown's participation was essential. And Yorktown only participated because American welders had patched her in 3 days. The broader lesson extended beyond carriers to every aspect of American industrial warfare. The same welding techniques, the same mass production philosophy, the same acceptance of good enough over perfect transformed how America built tanks, aircraft, landing craft, and every other weapon system. Traditional manufacturing emphasized quality. American wartime manufacturing emphasized quantity and speed. Both approaches had merit. In total war, quantity and speed won. By 1945, American shipyards were producing carriers, battleships, cruisers, destroyers, submarines, and auxiliaries in numbers that Japanese industry couldn't match. The US Navy had become larger than all other navies in the world combined. That dominance rested on industrial techniques pioneered by Liberty shipbuilders and perfected by damage control teams, who kept carriers fighting with welding torches and determination. When Japan surrendered in August 1945, their remaining carriers were mostly inoperable. Not from battle damage, but from lack of fuel, lack of aircraft, lack of trained pilots, and lack of spare parts. They'd been unable to maintain their fleet through the final year of war because their industrial base had collapsed under American bombing and naval blockade. American carriers, meanwhile, were operating at peak efficiency. The fast carrier task forces that supported the invasion of Okinawa and struck the Japanese home islands represented the most powerful naval force ever assembled. And embedded within that force were thousands of welders, damage control specialists, and repair technicians whose skills enabled everything else. The post-war U.S. Navy institutionalized the damage control lessons learned during the Pacific War. Every sailor received basic damage control training. Every ship deployed with extensive repair equipment and trained welders. The philosophy that ships should be able to repair themselves at sea became doctrine. When American carriers deployed to Korea, Vietnam, and every subsequent conflict, they carried that capability forward. Modern American aircraft carriers are vastly more sophisticated than World War II vessels, but they still maintain the same damage control philosophy. Every carrier has workshops, welding equipment, spare parts inventories, and trained personnel who can perform battlefield repairs. The technology has evolved, but the fundamental principle remains. Don't wait for a shipyard. Fix it now. Keep fighting. The contrast with other naval powers persisted for decades. Soviet carriers that suffered significant damage typically withdrew to port for repairs. British carriers operated under similar limitations. The U.S. Navy remained unique in its emphasis on self-repair capability and rapid damage control. That advantage proved decisive in World War II and remained relevant throughout the Cold War. The welders who made this possible were ordinary people doing extraordinary work. They came from farms and factories and small towns across America. Most had never seen an ocean before the war. The Navy trained them in weeks and sent them to sea with welding equipment and instructions to keep ships fighting. They did exactly that, through skill, courage, and sheer stubborn refusal to accept that damaged ships had to withdraw from combat. Captain Elliot Buckmaster, who commanded Yorktown at Midway, wrote in his after-action report that the ship's survival through multiple attacks was due entirely to the damage control team's performance. He specifically praised the welders who repaired steam lines under terrible conditions and the hull repair parties who patched bomb damage while under air attack. His report concluded that American damage control had proven superior to enemy offensive capabilities. The Japanese could damage American carriers. They couldn't sink them fast enough to matter. That conclusion held true through the rest of the Pacific War. Japanese aircraft, submarines, and surface ships hit American carriers repeatedly. Some sank, most didn't. The ones that survived did so because American welders patched them faster than Japanese forces could finish them off. It was a race between destruction and repair. The welders won. The 6-hour figure that gives this story its title represents the ultimate expression of that advantage. 6 hours from catastrophic damage to resumed flight operations. 6 hours during which welders covered holes, electricians restored power, mechanics repaired aircraft elevators, and firefighters suppressed blazes. 6 hours that seemed impossible to Japanese admirals planning attacks. They'd calculate that putting 3 bombs into an American carrier would disable it for the duration of the battle. They'd be wrong. The carrier would be back in action before sunset. Their intelligence was correct about the damage inflicted. Their assumptions about repair timelines were completely wrong, because American damage control operated under different rules that Japanese naval tradition couldn't match. This wasn't Japanese failure. It was American innovation driven by industrial necessity and enabled by welding technology that most navies hadn't fully adopted. The Americans had stumbled into a competitive advantage almost by accident. Liberty ship construction had required welding because they didn't have time for traditional riveting. Carrier damage control adopted welding because it worked faster. The cumulative effect was a navy that could absorb punishment other navies couldn't survive. When historians analyze the Pacific War, they focus on battles like Midway, Philippine Sea, and Leyte Gulf. They discuss strategy, intelligence, leadership, and luck, all valid factors. But underneath those dramatic surface events was a more fundamental advantage. American carriers could be repaired at sea. Japanese carriers couldn't. That difference, measured in hours and days rather than grand strategic concepts, determined which navy could maintain sustained combat operations, and which navy had to withdraw damaged vessels for months-long repairs. The men who created that advantage worked below decks in conditions most people can't imagine. Temperatures exceeding 130 degrees, toxic fumes that burned lungs, darkness broken only by welding arcs and emergency lighting, the constant threat of secondary explosions, flooding, or structural collapse. They worked in these conditions not because they were heroes seeking glory, but because they were sailors doing their jobs under terrible circumstances. Their legacy is measured in carriers that kept fighting, battles that were won instead of lost, and lives saved because ships stayed afloat. No monuments bear their names. No medals commemorate their specific achievements. But every American naval victory in the Pacific depended on their work. The Japanese admirals planning operations against American carrier forces in 1942 and 1943 made reasonable assumptions based on how naval warfare had always worked. Damage a carrier severely enough and it withdraws from combat for months. Plan accordingly. Allocate your forces to account for the carriers you've damaged being absent from future battles. Those assumptions cost them the war. Because American welders operating under impossible conditions with inadequate equipment and improvised techniques had rewritten the rules. Carriers didn't withdraw for months. They withdrew for hours, long enough to get patched. Then they came back. Again and again and again until the Japanese ran out of carriers, aircraft, pilots, and hope. 6 hours. That's all the time Japanese admirals actually had before American welders returned crippled carriers to combat. 6 hours that changed everything. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.